Well, hello and welcome to Graphing Polynomials, Part 1. Before we start, I'm going to really define what a polynomial function actually is. So we know it's some sort of a function, and what is the definition? What stuff can we put in here, or are we allowed to put in here? So I'm going to work from the end of it here, because we technically tend to write these in what they call descending order. So you may or may not have at the end of it some sort of a number, okay, a constant as it were. And I'm just going to call it a sub 0. So this represents any number you want. Could be a fraction, could be negative, whatever. In addition to that, you might have some sort of a number, so I'll call it a1 times x to the 1, which we usually don't write that 1. Okay, so this you may be allowed to have, and in addition to that, we might throw in another number times an x squared. In addition to that, we might throw in some other number times x cubed, and so on. We can just keep going as far as we want. Okay, so what you're allowed to have is basically you're allowed to have any kind of a constant, okay, tacked at the end. That's what this a0 is. You may or may not have some sort of an x term, or an x squared term, or an x cubed, and so on. Okay. The exponent levels, the highest exponent levels in your polynomial function, they dictate what we call the degree of the polynomial. So why don't I do a couple of examples here. Let's say you had a polynomial function and it looked like this. Somebody says f of x equals 9x to the 4th minus 11x plus 2. Okay, so I look at this and I go, yep, there's a number, there's an x term. They left out the x squared, which is fine. They left out x cubed, and they went to x to the 4th. And so, oh, that must be a degree 4. Or a 4th degree polynomial, because my biggest exponent is 4. Let's do another example. Okay, so maybe in this one I have 4x squared minus 3x, and I think I'll leave the constant out. So I look at this and I go, yep, there's an x term and there's an x squared. That's my highest exponent, so this is a 2nd degree polynomial. Okay? What you don't ever want to see is something strange being done to x. X's are allowed to be squared and cubed and 4th and 5th and just plain old x. But you can't do, so these are the no-nos. No-nos. In the world of polynomials, you can't do things like an absolute value of x, or a square root of x, or a 1 over x, or x, say, to a negative 2. All of these things, or maybe even throw a sine x in there. These are fine if these are just numbers, but as soon as it's an x, okay, then it's considered a no-no, and it's no longer a polynomial function. Okay, what I'm going to do now is I'm going to give you an overview of what the graphs of these polynomials look like. So I'm going to clear off the screen, and what we're going to do, I'm going to try and fit the whole thing in here, is we're going to start with your most basic polynomial, something like y equals x. The graph might look like this, just because if you recognize it, oh, it's linear, right? It's linear, so the graph would be a line. And so this is a 1st degree polynomial, so I just put that in there, 1st degree, and the graph is a line, or it might be like this. If we put a negative sign in front of that x, it might be a downhill line. Okay, so let's get to the new ones here, or maybe we remember these ones. The 2nd degree is called quadratic. Okay, and a quadratic graph, basically it's like taking the front end here and putting a bend in it. Okay, so we got our parabola opening up. Or we might have a negative in front of the x squared, and this would cause the parabola to open down. Okay. Now, let's move to the new ones here. How about x cubed? By the way, this is called cubic, or third degree. And what you do is, just like we took the left side here and we put a bend up, take the left corner here and make a bend down. So you get a kind of a basic graph that looks like this. Okay. Sometimes the little bumps aren't quite even. You know, get a big bump here and then hardly any bump there. But that's the basic shape. And if we throw a negative in front, basically we're going to flip the graph over. So it's like taking the left corner here and making a bend that goes up. Okay, so it might look something like that. And we're going to keep going. Two more to look at. A fourth degree is called a quartic. Okay, and a quartic means take that left corner and put a bend in it. So basically you're going to get a graph that looks something like that. And if we put the negative in front of the x to the fourth, all we're going to do again, take that left corner and bend it so it bends down. So what you can see happening here is every time we raise the degree of the polynomial, it seems like we just throw in another little bend, and that's absolutely correct. These last guys here that we're going to look at are called quintics. So again, take the left corner and put a bend in it. Okay, so that'd be to the fourth, and oh, up we go. There it is. Okay, and then same thing over here. If I put a negative in front, then I know I'm going to take this left corner here and bend it back up. So let's see if we can draw that fairly well. All right, so something like that. Notice one thing, and that's where I'm going to stop. When it was first degree and third degree and fifth degree, one side went down forever and the other side went up forever. It didn't matter if we flipped it or not. Whereas the ones that have an even degree, okay, they're either both pointing back up or both pointing down. And even though you might throw extra wobbles in, they still both point up and they still both point down. And I think that's probably enough for our first look at the big picture on graphing polynomials. So that's where I'm going to stop right now.